Welcome everybody to Kirkham Tutoring. In this video we will go over ionic bonds and how to write correct formulas for the proper elements with the proper subscripts. So to start off, we're going to look at our periodic table right here, and we're going to start off by going over oxidation numbers. So we all know that oxidation numbers are the number of electrons an atom is willing to gain or lose to get to the full outer shell. So if we look at the right side of the periodic table, I can tell you that these three rows of groups of elements are going to have negative oxidation numbers. And they're all trying to get to 8 valence electrons like the noble gases. And we can tell how many valence electrons each element has based on the number of group they're in. So this group's going to have 5 valence electrons, this group's going to have 6 valence electrons, and this group's going to have 7 valence electrons. All these are trying to get to 8 valence electrons like the noble gases. So if we're trying to get from 5 valence electrons, 5 valence electrons to 8 valence electrons, we're going to have to add 3 electrons. So nitrogen will gain 3 electrons. Now, people would usually think, oh, this means plus 3. No. For some reason, this just means that we're going to write 3 minus here. And that is an anion. Remember, anions are negative, and when we get to the positive oxidation numbers, those are cations. So we can write up here, anions. Now, this goes for oxygen too. Oxygen needs 2 electrons to get to 8, so there's going to be 2 minus. And fluorine and the group of fluorine, so chlorine, bromine, iodine, all need only 1 valence electron. So it would be 1 minus. Remember, we can write this as just minus, right? Yeah. So that's anions, and they're all trying to get to a full outer shell with their valence electrons, which is 8. Now, going to the left side of the periodic table, if we look at cations, these elements are going to be positive oxidation numbers called cations. So lithium has an outer shell with only 1 valence electron. That's kind of unstable. It makes lithium very unstable actually, and it reacts very aggressively with water and other compounds. So to get more stable, it's going to try to get rid of that electron. So it's going to lose that electron, and it'll just keep its 2 first shell electrons, and that's going to make it it's losing 1 electron, so it's going to make it have a positive oxidation number. Now for beryllium, magnesium, calcium, they're trying to give away 2 electrons, so it's going to be a 2+ oxidation number. So that's pretty much it as far as oxidation numbers go. And when writing compound formulas, it's actually pretty easy. Now, compound formulas, for example, are when we have 2 elements such as lithium and, let's say, sulfur. Now we know that lithium, because it's in group 1, has an oxidation number of positive, and sulfur is in group 16, so it has an oxidation number of 2 minus. Now the way this works, it's very simple. We want to get to the formula LIS. However, that's going to have a subscript somewhere in there because they're not both just 1. So because there's a 2 in there, we're going to crisscross these. So lithium's oxidation number goes down here, and sulfur's oxidation number goes down there, which means it'll be Li2S, and we call that lithium sulfide. That goes for any ionic bonds. We're going to call it, for example, sodium chloride, barium oxide. We always do the "ide" at the end. So, for example, more practice would be sodium chloride. Sodium chloride is actually table salt, if you didn't know that, and it's a very stable compound, and it's a pretty simple formula to write. So we have sodium and chlorine, both have 1 and -1. So if we crisscross these, it would just be 1 and 1. When we're writing subscripts, we don't have to write the 1. It's kind of implied that there's just 1 in there. So we would just write sodium chloride. Let's do one more. So calcium, let's do calcium and oxygen. So calcium and oxygen, we have calcium and oxygen. Calcium has a 2 plus oxidation number and oxygen has a 2 minus oxidation number. So technically we could write Ca2O2, but the proper way to write that would be CaO. That's because we don't need to put the 2's in there if they're the same oxidation numbers and the same number of atoms. So rather than writing Ca2O2, we can just write CaO. And that's also the same reason why Kf is Kf and not K1F1, or sodium chloride. So whenever oxidation numbers are the same number, like -2 and +2, the formula is just going to have no subscripts. It'll just be the elements. So I think that's pretty much it as far as ionic bonds go. I hope this video was helpful, and please be sure to check out the other videos on this channel.